right, there we go. And then the other way for the other integral, it could be 1 all over a squared plus u squared, and then du. Either one is fine though. Now, as I go through 1 through 4, it's going to sound like kind of redundant. Certain parts, if you feel like you don't need to write, you don't have to. But I'm going to write it for teaching purpose. All right? So, here we go. The first one has to do with arcsine or arctangent. If it's got a minus. Arcsine. So, let's go ahead and label the following. We have to label out what is u is equal to and what is a is equal to. So, I'm going to go back to the formula. If a squared is 4, what is a alone? 2. If u squared is x squared, then u alone must be x. And then I'm going to derive it. Du is equal to dx. So when I rewrite this, instead of our dx, I'm going to put in du. So we have du is equal to, or du all over. And I'm going to leave it in terms of a and u. You don't have to. So let's go ahead and mimic the formula that we have right above. It says I need arcsine, and the ratio I want inside the argument is u over a. What was represented by u? X. What about a? 2. And I need plus c, and that's it. So again, if it seems like that's extra information, you don't have to write that piece, okay? Certain questions you will have to in the end, which I'm going to on number 2. You guys know I'm recording, right? Okay. All right. So on the next piece, let's write out what is a is equal to. So if I know a squared is equal to 2, what is a alone? Square root of 2. And if I know u squared is equal to 9x squared, then u alone must be 3x. And when I derive, I get du is equal to 3dx. And when I compare, do I have a 3 along with the dx from the original problem? So I'm going to move it over.
Why is it 3dx?
Can you explain more?
Because on this right here, if u squared is equal to 9x squared, and you square root on both sides, square root of 9 is 3. Square root 3x. Good? Okay. And it's okay if you have to write that piece. Then I have dx. So when I rewrite this, let's go ahead and throw the 1/3 outside. And instead of dx, I'm writing out du. And I want to write everything in terms of a squared and u squared. Again, if you want to write it with 2 plus 9x squared, go for it. But I want to make it look like the formula. So then that's going to give us the following. It says 1 over a. So that gives me 1 over, who is my a represented? Radical 2. And notice that 1/3 that I already took out. I need to leave it outside as well. Then I have arctangent. And the ratio for that one is u over a. What is u? 3x. What is a? Radical 2. And I need plus c.
How do you know which formula to do?
If it's got a plus sign, you go into the arctangent. If it's got a minus sign, you go to arcsine. Okay? All right. Let's go on to number 3. So I say it's more like matching, okay? So on this one, let's go ahead and write out the following. We know our a is equal to. So if I know a squared is equal to 1, what is a? 1. And if I know for the u squared, I think I'm going to write this out. U squared is equal to e to the 2x. So that means u alone must be what? E to the x. So let's derive. We have du is equal to e to the x dx. And it looks like I have everyone satisfied. So let's rewrite it. So I have the integral of du over. And again, I'm going to leave it in terms of a and u. So when I do, we're looking at arcsine. So if you look at the formula above, arcsine has what over what? U over a. So my u is e to the x. And what about our a? Is that 1 really needed? Not really. Plus c. and we're done. All right, number 4, we have to separate the fraction first, one with the x and one with the 2. So when I do, we'll get the following. We have the integral of x over my denominator, dx. And then I have the 2 with the denominator. Essentially, it's 2 different problems, if you want to think of it that way. But I want you guys to look at the first one. What is different about the first one from the formula that's given to us on the top? What magically is there? Dx was already there. The x. Okay? So far my numerator was like a constant, right? In this case, that's not a constant. So here's the idea. The second fraction is what we did today. First fraction is what we did last week, okay, in terms of u. So let's worry about the second one. On my second one, I want to go ahead and bring the 2 to the front. And when I do, we can go ahead and make it look like the arc sine. Bring the 2. So we have 1 all over square root of 9 minus x squared dx. So now we can go ahead and assign what is a and what is u. So what is a? 3. What is u? X. So if I go ahead and match that according to my arc sine, that's going to give us, I'm going to leave a 2 right here, arc sine. And the ratio I want inside the argument is u over a. So I have x over 3. Then I have plus c. Since I wrote plus c one time here, when I anti-derive on the next one, I'm not going to worry about the c, okay? So this part is from last week. So let's do all that work over here. So as a reminder, what we did last week was we rewrote it first of all to make it a non-fraction, which gives us integral of x times a quantity of 9 minus x squared to the negative 1/2 dx. And we let the inside become our u. So we have u is equal to 9 minus x squared. So du is negative 2x dx. When we compare, what is missing? Negative 2. Let's bring it over. And when we rewrite, let's bring the negative 1/2 outside of the integral and write it in terms of u. Then I have du. And then we'll integrate. So quick reminder on integration. I'm going to leave the outside alone. It was 1 over. Who is my new power when I add 1 more to that? 1/2. U to the 1/2. And if you want to write plus c, go for it. But I've already wrote it one time at the end, so I'm not going to need another one. And the only one that I want you to actually compute after this will be the fractional part. What would all that give me? Negative 1, good. So we have negative 1, and then for the u, when I plug the 9 minus x squared, we'll get this piece. And again, if c makes you happy, add the c. That is going to go in front. So let's copy that right here. Negative of that quantity. Ooh. There we go. And that is our final answer. So again, essentially it's 2 different problems. Okay.
Long division.
Long division, that's right, Xavier. All right, so let's go ahead and practice long division. And we need all of our placeholders. So if there is any placeholder missing, we're gonna have to put in a 0. So I have plus 0x squared plus 0x minus 2. And on the outside, we have x squared. Oh, let's write the 1 in front. Plus 0x plus 4. So quick reminder on long division. 1 times what is 3? 3. I need 3 x's and I already have 2, so how many more do I need? 1 more. Now I need to multiply it back with the outside. So we get 3x cubed plus 0x squared plus 12x. And all of our degrees should be lined up. What do I do after that? Make it opposite. So when I do the first term, will always cancel, but in our case, it looks like the second one cancels too. So I have negative 12x. I'll bring down the next one. Can I go on any further if that cannot go into this one? That is our remainder. He is so proud. All over our outside. So let's write this out. So we're looking at integration of 3x plus negative 12x minus 2 all over x squared plus 4 dx. And that really in the end is two different integrals. So let's write it as two different integrals real quick. 3x dx. And then we have plus of the second portion, the 12. But can I further simplify something else? Not simple, further split. Can I split this one into two different equations?
X plus 2.
Uh-huh. So I know I'm going to leave the first one alone.
X plus 2.
That will give us plus negative 12x with our denominator. And then our negative 2 with the denominator. What can I bring to the front just by looking at this? Can I bring this to the front before we integrate? Yeah?
Yeah.
But I'm going to stop right there.